Assalamualaikum and hello. Welcome to my proposal presentation. I am Ain Karina binti Muzaman with metric number S56118 from Bachelor of Science Chemical Sciences from Faculty of Science and Marine Environment, University Malaysia Terengganu. My final year project title is Highly Fused Aromatic Chalcones as Potential Organic Light-Emitting Diodes, OLEDs, supervised by Professor Dr. Wan Muhammad Khairul bin Wan Muhammad Din.
I will begin by introducing my proposal project. Most people conceive of molecular electronic as single molecule that are either the active element in hybrid electronic or combine a variety of fundamental tasks required in computing. Prior to more improved development, liquid crystal display (LCD) was a technology that grew in parallel with global advancement. However, owing to contemporary technological phases, people have recently mainly used LED as lighting indicator in electronic equipment. Organic light-emitting diodes OLEDs, a new type of LED display. Since the demanding of light has been increasing, to fulfill the application, various of the development have been discovered. Almost all electronic processes in nature take place in molecular structure, from photosynthesis to signal transduction. A typical OLEDs feature a multi-layer structure made of stuck organic compound layer. In order to attain high performance, an efficient OLED must have a Hall transport layer (HTL) and an electron transport layer (ETL) as essential layer. Next, some background on my compound. Fused aromatic chalcone tend to be like a molecular wire as a conjugated molecule, as the third-order nonlinear optical response is caused by the delocalization of pi electrons within these double bond and benzene rings. Because of the conjugated system and the delocalization of the compound's pi electron, the molecule has the potential to exhibit electrical characteristics. The conjugated organic molecules and their derivative are desirable compounds among the numerous types of molecules that can serve as molecular devices. This is owing to their unique electron transport structure. Not only that, but the impact may be applied by improving their electronic donating group's capability. Secondly, in view of the problem statement in this study, basically there are some issues, which is first, the flaw of this technology, such as low lifetime span and higher cost. Next, fused aromatic chalcone have the potential to be bright and valuable. And lastly, although the use of chalcone conjugated system is still relatively new, this research has a promising future in many electrical device applications due to their noticeable material for blue light transmittance and good crystallizability. Next, for the aim of the study. In this study, according to Weijer, ETA 2019, thin layer of organic material sandwiched by two electrodes is a common fundamental construction of an OLEDs. Multi-layer OLED structure, which are typically composed of high work function indium tin oxide (ITO) anode, an organic Hall transporting layer (HTL), an emitting layer (EML), which is often doped with highly fluorescent or phosphorescent molecules, and an electronic transporting layer (ETL), and low work function metals used as a cathode. To understand how OLEDs work, the theory must be understood first, which is based on their chemical and photophysical properties. There are three of major physical processes in how this technology works. As stated in introduction, conjugated fused aromatic chalcone system, where the push and pull effect is represented in the donor pi acceptor system, allowing electron movement and increasing of charge transfer mobility. Fused aromatic chalcone photophysical and photochemical capability, according to Lee et al. 2012, have long been overlooked, despite the fact that some chalcone derivatives with suitable electron push-pull pairs are known to be luminous. Commonly, Kleisen-Smith condensation, known as best catalyzed crossing-aldol condensation, and generally by Gaonkar and Vignesh, 2017, the best reagent used for the condensation, for example, sodium hydroxide (NaOH) and potassium hydroxide (KOH). Fused aromatic chalcones widely used in biological activities since the study in this field is more commonly, and the compound already has been used in industry for such a long time. However, in recent years, fused aromatic chalcone derivatives have demonstrated a variety of technical characteristics. The methodology that has been utilized to attain the purpose in this study, the computational study will be carried out by using density functional theory with the Bakish tree parameter exchange functional in combination with the correlation functional of Li, Yang, and Parr B3LYP 631GDP basis set will be used. These procedures are implemented in the Gaussian 09 program package. Synthesis pathway of proposed compound via Kleisen-Smith condensation. The evaluation of OLED's potential on this study, including thin film fabrication via deep coating technique, conductivity measurement recorded using Catley instrument, and electroluminescent testing, which monitored using an electroluminescent testing setup after gold film deposit in the ITO thin layer. For the expected result, due to the chalcone conjugation system, chalcone can glow in the visible light range, making them appealing and acceptable for chemical probes for mechanistic investigation and imaging. The fused aromatic chalcone derivative differ from the position of the substituent. From these three compounds, it should be seen that Fe, which is the functional attached is nitro group, is more intense to increase the fluorescent intensity due to the electron donating properties and the dipole moment of the functional group that attach that affect the charge transfer of the compound. By altering the polarity of solvent, which is the differ from each compound, the heteroaryl chalcone containing both an electron donor and acceptor system have been produced, which improve the fluorescent performance via intermolecular charge transfer. Last but not least, as shown in the table below, a graphical depiction of a timetable that supports in the planning, coordination, and monitoring of specific activities in this study is presented with latest progress is in September.
I sincerely appreciate your attention this morning. So to finish my presentation, I did like to say thank you.